Okay, so this is our numerical. Okay, it's given that a wire of resistor R is bent into a circular ring. Okay, a wire of resistor R is bent into a circular ring of radius R. Okay, so radius of this ring is R. Now we need to determine the equivalent resistance between points X and Y. Okay, between these 2 points, okay, we require to find the value of the equivalent resistance, okay, on its circumference when the angle X O Y, the included angle X O Y for this ring is given as alpha. Okay. Now, when we'll observe this thing carefully, what we are required to find is the resistance between the 2 points X and Y, and this is actually the parallel combination of the resistance of this length of wire and the remaining length of wire X and Y. Okay. For instance, what I mean is that suppose this length, the length arc XWY. The length of the wire XWY will correspond to some resistance. Okay, suppose this is indicated by RXWY. Okay, now this resistance, okay, this wire is in parallel, okay, parallel to the other wire which is XZY. Okay, so RXZY. Okay, that is the resistance of this wire, and these two resistances are in parallel. Okay, so what we need to determine is the value of this resistance, that is the parallel combination of RXWY with the resistance RXZY. Okay, so this is our aim, to determine the value of these two resistances. Now, in order to determine the value of the resistance when the shape of the wire is in form of a circular ring, that we have been given that the original resistance for the wire was R. Now, if we want to find the new value of the resistance when the wire is bent into a form of circle or circular ring, we need to determine what is the value of the resistance per unit length. Okay, so in order to determine the resistance per unit length, what we can do is we can divide the resistance by the circumference of the ring, okay, the perimeter of the ring. Okay, so that will give us the resistance per unit length. Okay, so resistance per unit length, if we'll find the value of resistance per unit length. this term, this would be equal to the resistance, the original resistance of the wire divided by the entire perimeter for the circular ring. So in this case, since the radius of the wire is r, the perimeter, the circumference would be 2 pi to r. Okay, so this gives us the resistance per unit length. Okay, now if we want to determine the resistance of this length of wire, okay, now we know from geometry that the length of the arc for an included angle alpha, okay, is given as the radius times the included angle. That means the length of this wire, okay, the length of this wire xwy is same as r times alpha. Okay, so the resistance, the new resistance would be the resistance per unit length multiplied by the length of the wire xwy. So that will give us the resistance xwy. Okay, so this would be r divided by 2 pi r times the length of the wire xwy, that is r alpha. So this is equal to upon 2 pi. Okay, this is equation number 1. Okay, this is the resistance of the first part. Now similarly we need to determine the resistance of the second section of the circular ring. Okay, now if we'll observe here carefully that we know that the entire angle for a circle, okay, the central angle for a circle is 2 pi radians. Okay, and in this case the angle included for this length of arc xzy would be 2 pi minus alpha. Okay, so our included angle in this case now it is 2 pi minus alpha. The radius again it is same as r. So the length of the arc lxzy, it would be r times the included angle, which is 2 pi minus alpha. Okay, so since the new length is this, so the resistance of the wire xzy, it would be equals to the resistance per unit length multiplied by the length of the arc xzy, and in this case it is r times 2 pi minus alpha. Okay, so what we will be getting is r times 2 pi minus alpha divided by 2 pi. Okay, this would be our equation number 2. Okay, now we need to determine the value of the equivalent resistance between the points x and y. Okay, so the value of the equivalent resistance between the points x and y would be the parallel combination of these two resistors. Okay, so we know from our last lectures that the equivalent value of the resistances when they are connected in parallel. Okay, in this case there are two resistance, so the equivalent resistance would be 1 upon R equivalent equals to 1 upon R1 plus 1 upon R2. Okay, so from here we can say that R equivalent is equal to the product of these two resistance divided by the addition of the resistors. Okay, so in our case R1 is Rxwy, whereas R2 is Rxzy. Okay, so when we'll substitute the value of the resistances what we have obtained in this equation, we'll be getting the value of R equivalent. Okay, so after substituting these values, we'll be getting R alpha upon 2 pi times R 2 pi minus alpha divided by 2 pi minus alpha divided by 2 pi. Okay, so after solving this, okay, we'll be getting an expression which would be R times alpha divided by, will cancel, could be 4 pi square to 2 pi minus alpha. Okay, so this is what we will be obtaining, okay, after solving this equation. Okay, so this is the value of the equivalent resistance between the points x and y. Okay, so this is how we obtained the value of the resistance when it was converted into a circular ring.